Hello everyone, welcome back to OmegaCodex. In our last video on minimal APIs, we got started with what it is and how to implement it in ASP.NET Core. You can find the link to that video up here. Now it's time to delve into the intricacies of handling responses when working with minimal APIs. Understanding how to manage the output of your API is fundamental to building efficient and scalable web services. We'll discuss about typed result and result classes and how these impact the design of your API. We'll compare their structures, discuss their strengths and weaknesses, and examine how they align with OpenAPI specifications. We will touch on the aspects of unit testing because ensuring your code not only works but is also maintainable and bug-free is what separates a good software from a great one. So let's get started. In minimal APIs, the way we structure our responses is crucial to the client-server communication. Essentially, there are three primary return types. First up, returning a string. It's simple and straightforward. For example, when you write app.mapget/hello and you return hello world, the framework processes this as a text response with 200 status code and the text/plain content type. This is go-to for text-based outputs. Next, we have generic T type. Here is where it gets interesting. If you return a complex object, the framework automatically converts it to JSON. So when your endpoint is like app.mapget/hello and you return a new anonymous object with message hello world, the response is neatly packaged in the JSON object with the status code 200 and application/JSON as content type. This is perfect for most of your data exchange needs in a RESTful API. So let's jump to Visual Studio and check these things out. So what I have here is the same code which we had used in the previous video, and let's get started with this one. So first we will add the Swagger UI to this one because last time we didn't add it. So for that, let's first add a NuGet package. So I'll open the terminal and I'll add a new package. Let's give it a few seconds to start the terminal. So let's do .NET add package and swashbuckle.asp.NET Core. So which will add all the required libraries for setting up a Swagger UI. So now that's installed, let's add the services. So builder.services.add endpoint API Explorer and builder.services.add Swagger Gen. And to the app, let's add use Swagger and Swagger UI. So with that, our Swagger UI is added. So to check the first type, /hello endpoint, and let's just run it. So let's go to our Swagger endpoint and we can see that it has set the content type as text plain and the expected value is string. So if we just try out, we'll just get hello world. And let's come back to our code and change it to anonymous type hello world. Let's build it. So it does an automatic reload. And now when we check for our hello endpoint, the media type has changed. Now it's application/JSON. It is automatically figuring that out and it is automatically converting it to a JSON. So those are the first two types, string, and then you have the generic type. Even you could use a concrete type. Let's say we use blog post, which we were using in our old example. In title, let's call it new title. Let's build it. Now when it reloads, it's serializing it and mapping it to blog post. So this was with string and the generic type. Lastly, the iResult type, which offers the most flexibility. Implementing the iResult interface allows for a custom response handling mechanism. This means you can exactly control how the responses are executed, allowing for a more fine-grained response strategy that you can tailor to your application needs. Working with iResult type, we can use results or typed results. Let's unpack the difference between typed result and results in ASP.NET Core Minimal API and why it matters. The results class provides a set of helpers to construct various HTTP responses. For example, results.ok or results.notfound. These methods return a non-specific iResult interface, which is versatile and can represent any HTTP response. It is useful when your endpoints needs to return different types of responses dynamically. However, this flexibility comes at a cost. Since iResult is not strongly typed, you don't get the benefits of compile time checking, which can lead to potential runtime errors. Enter typed results. This class provides similar helpers as results, but with a twist. Each helper method returns a specific iResult implementation. This means you get strongly typed results, leading to clearer code and easier unit testing. For example, TypedResult.ok with T not only returns an OK response but indicates the specific type of content being returned, making your API contract more explicit. Let's see it in the code. What we had done in our previous video as well, we had used this results class, which is a helper class with all appropriate methods to return proper responses. And if we go to the definition of it, we can see that it returns iResult for all the helper methods. So we can have an OK response, we can have not found, that is 404, or a no content, or created response. So different kinds of responses we can automatically generate, and it will return the response with appropriate status code. So here it is always returning iResult. So another one is typed result, but then it has similar helper methods as is there in results class, but then each method returns a specific iResult implementation. So here let's change our get method for getting all blog posts, and let's use result.ok, and let's call the same code, build it, and see how it comes up. So now when we check the blog post endpoint, we see that there is no description as such in the response type. It just says that you will get a 200 response and success. We don't come to know that what type of result it would produce. So to mention that, we have to use the produces keyword, which is this one, and we say that it would be a list of blog posts. So this way you will have to explicitly mention when we are using the results helper class. So now let's have a look. Now we have more details about what type of result it is going to produce. So it is still similar to what we were doing with generic type, but then here we are explicitly mentioning that we'll get an OK response and then or a 200 status code with the list of blog posts as a response. So now let's come back to the code and change it to use typed result. So instead of this, let's call typed results, and that's it. So if you note, we have removed the produces call and we have replaced results with typed result. Now if you come back and see, it behaves the same way like it was when we were using the produces method. So with typed results, so it is able to understand what kind of response you're sending back, and then it is generating the appropriate OpenAPI metadata to be displayed on the Swagger. If we look at the methods also with respect to each of these classes, if you look at the OK method for typed results, you can see that it returns OK with the type as list of blog post, and it is returning the OK result when we are using the typed result. But when you come to results.ok, the response is an iResult. So in case of responses from results class, it would always be iResult, but when we are using typed results, the responses are specific to the type of response we are returning, and that way it is more type safe, and which avoids any kind of type checking and casting. when we are working with typed results. OpenAPI relies on the metadata to document the API endpoints. With results, you manually annotate endpoints with expected response type using the produces method. With typed result, this metadata is automatically inferred, simplifying your code and reducing the overhead. This approach not only keeps your endpoint definitions cleaner, but also ensures that your API specifications are always in sync with your code. When working with minimal API responses, understanding the compiler behavior is crucial for writing clean and maintainable code. With results class, you can return various iResult types from single endpoint without specifying the exact return type, thanks to C#'s type inference. This is quite handy when your endpoint might return different status codes or data types based on business logic. However, when it comes to typed results, the compiler requires more information. Since the method in typed result returns a specific type, you must explicitly declare the return type of your handler. This explicitness is beneficial for compile time checking, ensuring that your endpoints return exactly what they are supposed to. Here is an example. If your endpoint could return either an OK result with a to-do item or a not found result with results, you could write a method that compiles fine because the return type is inferred as iResult. But with typed results, you must use the results T1 and Tn generic union types, which provide the added benefit of endpoint metadata retention and compile time checks. Look at as an example here. We are returning results.ok and result.notfound depending on whether we are able to find a blog post for the given ID. Now if we change it to typed results, you can see that it would give an warning, because typed result.ok would return an OK response and not found would return a not found response. So they are different and you are trying to return two different types. To resolve that, what we have to do is add or explicitly mention the return type. So what we have to tell to the handler is that to expect both kind of responses. So to do that, we have to use the results class and then mention what all we can send. So we could either send a OK blog post or we could send a not found. So now it knows that these two types are possible. So when working with typed results and when you face similar situations where you could return multiple types of responses, you can use this trick to use the generic union type and also provide an additional benefit of maintaining the metadata on your Swagger UI. So now when we run this, let's have a look on how does it impact on Swagger UI. We had updated the get blog post by ID method, and now if you come here, you can see that in the responses it has properly mentioned what type of responses you can expect. So with success you will get a blog post or you could get a 404 response. So this way, without much of code, we were also able to define the metadata for Swagger. Now concerning unit testing, typed results provides a significant advantage. When testing an endpoint that uses results, you typically assert against the iResult interface, which may require additional type checking or casting. With typed result, the return type is explicit, making your tests more straightforward and type safe. This direct approach leads to a more readable test and eliminates the need for casting, which can be source of errors and complicate test setups. Now coming to unit testing, let's make few more changes so that it becomes easier for us to test the code. So to start with, let's first add a class blog post endpoints, and this will work as a extension method class for us. Let's call public static root group builder, and we will call it map blog post endpoints, and we'll call group root group builder and blog post group, and let's return this blog post group in this method. Now what we will do is, in the previous video we already had grouped all these endpoints to blog post. So let's just pick all these endpoints and put it here. Just we'll replace it with this one and maybe call it blog post API group. So done. So now everything is here, and I wonder why it didn't rename this. So now what we can do is just call map blog post endpoints, our extension method, and maybe just give it some tag. So with this, even our program.cs became a bit cleaner, and it will help us to organize our code better. And the next thing I want to do is remove these inline lambda calls into separate methods so that it becomes easier for us to test. So I'll just update the code to speed things up. I have individual methods for each of these endpoints. In those methods, it's essentially the same code which we had as our anonymous methods or lambda calls. So now let's add a test project. I'll add a new project. I'll select an XUnit test project and call it minimal.webapi.tests. We'll keep the framework as 7 because that's what we are using, and give it a few seconds to create the project. Yeah, so we have the project. Let's just rename this class to blog post tests. So to help with our test, I'll just add a helper class which would help me mock the DB, and I'll just paste the code for that, which essentially I'm doing the same thing which we did in program.cs. We're just creating an in-memory DB, and I'll add the entity framework core library for this. Also, I'll add the project reference. Okay, so I'll just add the project reference. So we have this helper class, and let's create our first test. So let's call it get post returns not found if not exists. So here we will just create our context, new mock db dot create db context. Just miss the using, and our result is equal to wait. Now what we want to do here is our blog post endpoints class, and now since we have moved all our code into individual methods, that makes us easy to test those methods in our unit tests. So let's call id1. So now we know what type this will return, because if we look at the response type, we know that it is of results, and which helps us in specifying the test more effectively. So results, okay, and then we have blog post not found. What this will do is check the type is correct, and in our case it's a not found result. So let's just typecast it and check that it is not null. So let's open the test explorer and run our test. Now our test has run successfully, and I'll just put the next test to speed things up. So it's the positive scenario where we have the object, and I have added a blog post to the context, and then I'm looking for it. So now again we know the result is of this type, and then we are looking for the OK result. Now the benefit of using typed result is that we know exactly what kind of result we can expect from it, and we can check against that type, or we can even get the results in that type. Let's see that by creating another test. Let's call it create post returns new post. We have context, and let's create a new post object, and what I will do is blog post endpoints create post and context. So that's what it expects, and here the return type is iResult. So now Now to validate with this, I would have to typecast it and get to the appropriate result, and I'll have to go back to the method and try to understand that what it would return, and based on that I'll have to write my test. But if I'm using a typed result, say I change it to typed result, it would see it still doesn't give an error though my return type is iResult, because whatever typed result is returning is a type of iResult, but then it is returning a specific type. So here, as we can see, it will return, in this case, created of blog post. So we can also change it to that type. Now when we come to unit test, we can even specify here the same type. So that way we are already doing the type checking and making it type safe and removing the risk of the test failing because of such issues. So now you can just check that it is not null, result is not null, and equal, just to check that result dot value, which will have the blog post object which was returned, and title. And we can also see that ID is not equal to 0. So it will definitely have some ID assigned to it. So let's just try running this. So now the test has successfully run. So this way, using typed results ensures that the code is type checked properly, and it makes it easier for writing the unit tests. In conclusion, while results provide a quick and flexible way to handle various response types in minimal APIs, typed results offers a more robust and type-safe approach. By enforcing compile time checks, typed result minimizes the risk of runtime errors and facilitate a better integration with tools like OpenAPI for automatic documentation. Remember, the choice between results and type results should be guided by your API's complexity and the level of type safety you want to enforce. As best practices evolve and APIs become more sophisticated, embracing typed results could lead to cleaner, more maintainable and self-describing code. So, consider the architecture of your API, the needs of your team, and the benefits of each approach when deciding which to use. I hope this video has illuminated the nuances between typed result and results and given you the knowledge to apply them effectively in your projects. Drop in your thoughts in the comment section below, and if you have found this video helpful, give it a thumbs up and don't forget to hit that subscribe button so you don't miss out future content from OmegaCodex. Continue your learning journey by following on to the next video here. This is Sanal signing off. Until next time, keep coding smart and keep innovating. Adios.